Hey guys, welcome back to the last set of questions for the video in probability and stochastics. Uh, Today we'll be looking at homework 11, question 2. It is suggested that the following functions of v, and that is a, f of v equals exponential of minus absolute value v, when is equal to sine square v over v squared, and when it is 1 when the absolute value of v is less than or equal to alpha, and 0 when it is greater than alpha. So it's suggesting that these following functions of v may represent an autocorrelation function of a WSS stochastic process by setting v to tau, or a spectral density function by setting v to omega, or both. So they're asking which functions f of v may represent either or both, and we're asked to explain our answers. So for the first one, f of v equals exponential of negative v absolute value. So this can represent an autocorrelation function because our f of v is even, and since it is also less than or equal to the exponential of 0, and we can write out the Fourier transform of this as 2 alpha over alpha squared plus omega squared. This is it is non-negative. So, and since our f of v is greater than or equal to 0, it can represent a power spectrum. Okay, b, we have f of v equals sine square v and v squared. So this also represents a autocorrelation function because sine square, I believe, we should put this as omega when you're setting v to omega. Sine square omega over omega square is even, and sine square omega over omega square is less than or equal to basically 1, you know, like the limit of v of omega when it approaches 0. Over here, it's equal, less than or equal to 1. You can also take a look at how sine square of omega, the Fourier, is like a triangle, so it is non-negative, and since sine square omega over omega square is greater than or equal to 0, our f of v can represent a power spectrum. So the last one, Fv is 1 when the absolute value of v is less than or equal to alpha, and is 0 when it is greater than alpha. So this cannot represent an autocorrelation function because the Fourier transform to sine of alpha omega over omega is not non-negative. Oh wait, I think I made a mistake. Oh. This is all tall, actually. Sorry about that. Yeah, sorry about that. It cannot represent an autocorrelation function because the Fourier transform, a 2 sine of alpha times omega over omega, is not non-negative. But however, since our f omega is greater than or equal to 0, this can represent a power spectrum. Alright, guys, It's been a trip. Thank you for watching the homework series, and I'll see you around in another class.